Hey there, we are once again talking about compound probability, but this time we're going to be talking about dependent events. Last time we were talking about independent events, those were two events that didn't affect each other. Now we're going to talk about dependent events. So since an independent event, as I mentioned in the last video, did not change the result of the second event, a dependent event will. So for instance, the result of the first event will affect the outcome of the second event. An example of this would be taking objects from a group without replacing them. What this means is, for instance, if you're drawing cards out of a deck of cards and you're keeping them, let's say you're playing poker or something, if you take one card out of a deck, well, now you don't have 52 cards anymore, you've got 51 cards in the deck, and if you take another card out, you've only got 50 cards in the deck. So your probability is going to change a little bit as things are going along. Let's take a look at an example of what this looks like in a problem. So for instance, you're going to draw 3 cards out of a deck, and what you want to find out is what is the probability that you draw a 7, and then a 2, and then another 7. Well, if we write this out, we want the probability of 7 and a 2 and 7. So we've got 3 things that we want. And if you remember from the last video, the word and means multiply, so we're going to be multiplying the probability of each of these together. Well, first off, before we've drawn anything out, we know a regular deck of cards has 52 cards total. So we know that our probability of our first thing is going to be something over 52. I have something over 52. Well, there are 4 7s. In fact, there are 4 of each of the cards in the deck to start with. So we've got 4 7s total out of 52. So the probability of drawing our first 7 here is 4 out of 52. Now we've drawn that 7 out. We're hanging on to it. We want to figure out what our probability of drawing a 2 is. Well, we've got the word and here, so we know we're going to multiply, so I'm going to put a multiplication symbol down here. And 2 is the next number we want to draw. Well, we know that we've got 4 2s still in the deck, so we've got 4 on top. But now that we've drawn 1 card out of the deck, we no longer have 52 cards just laying in the deck because we've got that 7 that we drew out. So now we have 51 cards down at the bottom. So our second probability is 4 out of 51 because we've already drawn 1 card out here. That was our first event when we drew out the 7. We're drawing out a 2 now because we've already drawn 1 out. That gives us a 54 on bottom, but there's still 4 2s in the deck, so that's why we have the 4 on top. Lastly, we want to draw out a second 7. We know that we've drawn 2 cards out. We drew out the 7, we drew out the 2, so that means that we've got 50 cards left in the deck now. But this number on top is not going to be a 4 because we no longer have 4 7s left in the deck because we drew 1 out at the very beginning there. So now we actually have 3 7s in the deck. So here, this is going to be 3 over 50. And so we have 4 over 52 times 4 over 51 times by 3 over 50. This is going to be the whole compound probability when we multiply these 3 together. We're going to multiply these together just like regular fractions, so we multiply all 3 of our numerators, so 4 times 4 times 3, and then 52 times 51 times 50. It's a good idea to have a calculator here because I don't know about you, but I can't do this in my head. If I multiply 4 times 4 times 3, that's going to give me 48. And if I multiply 52 times 51 times 50, that's going to give me 132,600. Like that. This would be the fraction of our probability, but as you know, I almost always want you to have the decimal as well, so go ahead and divide this out. And if you actually divide this out, you would get 0.0000362. So a very, very tiny number, which means you're highly unlikely to have this situation happen.